Me doing this problem should help you do number 9 on the homework. Remember, you can pause and draw this in your notes anytime you want, and then just click play to replay. Okay, so let's do A. So A is f of 0 and f of 6. So what I'm going to do is this is really when x equals 0 or when x equals 6. So I'm going to go over to my graph, and x equals 0 at this point right there. So it's 0, 0. So when x equals 0, the output is also 0. And then when f equals 6, so right here, when x equals 6, my y again is 0. So that's that one. So for B, f of 2, again, x equals 2. So I'm going to go over to where x equals 2, and I've got this point right here. So y equals negative 2. So my answer is negative 2. For negative 2, I'll color code this in pink. So when x equals, negative 2, let's make that negative. I'm going to go over to negative 2, and I've got this point here. They label it for me, 1, because y equals 1. So those are my answers. So for this one's a little trickier because it's not clearly laid out in my graph. But if I notice, I've got to go to x equals 3. So x equals 3 about, I don't want that to happen, about right here. So there's my point. And so it's negative. It's below that line. So at x equals 3, since it's below, it's negative. So f of 3, is negative. So for f of negative 1, it's similar. So I'm looking at the area between here. Negative 1 is like right there. So if I'm at negative 1, I'm going to go up. I'm going to go positive. So f of negative 1 is positive. All right, part E says for what values of x is f of x equals 0? And I'm going to, again, just think of this as y. So I have to go and pick out this point, and this point, and this point. I'm just looking at my x-intercepts because this point is 4, 0, y is equal to 0, and that's 6, 0. So and I could do set notation. So I separate my solutions by commas, 0, comma 4, comma 6. Sorry about that bracket. Comma f of x is equal to 0. That's my solution. So f of x is less than 0. So when is y less than 0? So if I go y is less than 0 down here, they're going to be negative numbers because I've got my negative y values right there. So it's between 0 and 4. And at 0 and 4, they equal 0. So we don't include that. So our answer can be f of x is less than 0 on the interval, because this is an interval, and they don't include, so this is what's called interval notation. When you don't include them, you put a curvy, just a parenthesis, 0, comma, and this is an interval, 4. And there is a poster on the chalkboard that kind of talks about interval notation. So G is asking for domain. So domain is our x values. So x's go from left to right. So if I think about this, I go from here, and I'm continuous all the way to here. And I even include those. Those are solid. So I go from -4 to 6. So if I want to do interval notation, which is what I did in part F, they include those. So that's when you put brackets, -4, comma 6. If I want to do set notation, I'm going to say x such that -4 less than or equal to, because it equals x, less than or equal to 6. For the range talks about our y values. So we're going to go from low to high. So we go here, and then our highest point is right here. And that's labeled for us at 3. Our y value is 3. So it looks like we go from -2, and we include that one, to 3. So again, set builder, we're going to, or excuse me, interval notation, we're going to have brackets because they include those. And then for set builder, we have y such that -2 is less than or equal to y is less than or equal to 3. So x-intercepts are just where it intercepts the x-axis, or the roots, or the zeros. We can we can answer that different ways. So the x-intercepts are at y equals, and then our solution set is at, oh, I'm sorry, we'll say x equals. I'll do this again. 0, comma 4, comma 6. The y values would just be 0 for that. So you want to label your x-intercepts, where they intercept the x-axis. J is the y-intercepts, so where it crosses the y-axis, and it better only cross once, otherwise it would not be a function. So it's at 0, 0, so the y-intercept is at y equals, and there's only one solution. So K is fun. How often does the line y equals -1 intersect the graph? So this is what I'm going to do. At y equals -1, I'm going to make this mark. So that's about where y equals -1, and I'm going to draw this horizontal line through my function. So how many times does it intersect the graph? Well, I see one right there. Excuse me, it's right there. And right there. So twice. So the line, we can write it off as a complete sentence. Y equals -1 intersects the graph 2 times. How often does the line x equals 1 intersect the graph? So I'm going to go where x equals 1, which is about there, and I'm going to draw a line, and it's a function, so my vertical line test pass, so it just does once. So you can write out the complete sentence, just like I did for K, but you're just going to say one time, or once. For M, what value of x does f of x equal 3, or y equals 3? So this could be more than once, even if it's a function, because it can go this way. But if I look, it just crosses right here at 5, 3. So for what value of x? So f of x equals 3 when x equals 5. And you could do set builder notation if you wanted to. For what value of x does f of x, or y, equal -2? So y equals -2 just once again, right here where x equals 2, at x equals 2. What are the zeros of the function? Well, the zeros of the function are the same thing as the x-intercepts. So we'd say the zeros are at x equals, and then I'm just going to list those x-intercepts again. Those are the same thing as your zeros. So 0, 4, 6. Okay, so this problem should help you do number 9. Try number 9. The answers are posted. Try A through F, and then check your answers. Try G through K, check your answers. Try L through O. Make sure you highlight whatever ones you still have a question on after you ask your neighbor. Thanks.